Welcome. Welcome, everybody. It's 6 minutes past 1, and it really is later than you think. It's later than I anticipated, but I'm delighted to see so many people here today. So this is the first lecture of a whole week of talks and presentations. And what I'm going to talk about today is climate and the things that are related to it, and why I am hoping to prepare you that the climate change is more advanced than you think it is. And actually, all scientists are taken by surprise at the events of last year and this year. And I'll go through some of those. Okay. So we are within the horizon of a systemic change. The climate is a system. The changes are already here. You've grown up with them. From my point of view, the long life, the world today, and the climate and ecology is very different than it was when I was young. And I'll show some of those changes. We've known for about 70 years that the burning of fossil fuel is driving climate change. It's not a new thing. Many of our politicians act as though it's only just happened yesterday. And by the way, when they get around to it, they'll change something. But you face very profound changes in your lifetime and in your professional life. If you're ill and you go and see the doctor or a nurse, the first thing they will do is read your vital signs, your pulse, your heart rate. In my case, how much do you weigh and how much are you eating? And you shouldn't be eating so much. But the vital signs of the Earth are very carefully measured today, measured by satellite. There are still hundreds of thousands of small weather stations around the world that are also contributing to this knowledge. But these figures are really important. 1.4 degrees is NASA's reading early last week. Over the year, it's very close to 1.5. And it is only 9 years ago, I think in the Paris Accord was 2015, that 194 countries, the leaders, signed up to promises about the changes they would make. And I'm going to evaluate some of those promises and see where we are today and what's coming. For many of you, these kind of scenes in lots of different countries, this is Paris last summer. Many of you will have seen these kind of experiences where it's so hot in cities that the city has to provide water for people just in their daily existence. Never mind for the people who have to work out in the fields or outdoors. There have been 6 IPCC conferences and papers produced. I think 28 COPs, hundreds and maybe thousands of science papers, but there is very little progress. And like in this country, promises that were made, the leaders very soon roll back on it and say, well, you know, it's not quite so easy, and maybe we'll do it next year. Or like in this country, where they promised 28 billion to be spent on a green agenda, they're now saying, well, not this year. And that is the story that goes back to 1957. It's never this year that they're going to make changes. This summer, if you can just look at all the little red thermometers, all around the world, there have been record heat measured from the Arctic and Antarctic and all the major continents. There have been far more intense hurricanes and cyclones than we've had in the past. A warmer climate means a warmer atmosphere. A warmer atmosphere holds more water, but it also holds more energy. So the intensity of rainfall and the intensity of storms is greatly increased. And in your lifetime, it's going to increase further. Okay. Something very scary from last year, they've only just discovered. All climate models and all governments assume that the ocean and the land and the forests will absorb carbon dioxide from the air and they will store it. But for the first time, the land and the trees last year, right across the world, did not store any carbon dioxide. No carbon was stored. These are, I've given all the citations for where these come from. And when you look back at this video on YouTube, whatever, you can trace through all the science papers that are for it. None of that is accounted for in climate models. So when people tell you, it's going to be okay, we'll invent something, someone else will invent it, and, we'll just suck all the carbon dioxide out of the air and everything's going to be fine. I will show you that it isn't. And your generation faced these profound changes. And as architects, it's going to be your job to understand those changes of what's coming in your own particular country or whichever practice you want to work in. And you'll be designing for things in 20, 25 years' time. Okay, amplifying feedback loops. We know something about this in our personal lives, right? You have thermostat at home for your central heating. Sometimes it works, yeah. And if you turn it up, you will increase the heating, and if you turn it down, it will turn it off. Right? That's a feedback loop. These are the primary feedback loops in the climate system. And each one of them is not isolated. It affects other ones. And I'll show in a little while, in the next few slides, how those changes affect each other. One of my students famously told me that they'd noticed there were 2 6 o'clocks in 24 hours. The first one is in the evening when they decide what lecture they're going to go and see, and then they're going to go out. And the next 6 o'clock is when they're on the way home in the morning. So it's 6 o'clock in the morning, you've been out all night, you're in a little cafe because that's the only places that are open at that time, and somebody is taking the sugar and piling it up on the table. It will assume a regular angle. But when there's enough, it will collapse and that angle will change. And that's a tipping point. You can't tell which single grain of sugar is going to do it. You can tell when it's close to it. And that's where we are with all of these. The sea ice in the Arctic, we're very close to having a completely free, ice-free Arctic in the summer. You might think that's not very important. It's a long way away. You've seen some nice movies about polar bears and things, but you're not going to go there. But it is changing your world. So when we talk about 1.4 or 1.5 degrees, that's an average all around the world over a whole year. Most places, at some point in the year, will have much warmer periods than that. And typically in the Arctic, we're 3 or 4 degrees warmer than anywhere else in the summer months. And the ice melts. Ice is nice and shiny, and it reflects a lot of light back into the atmosphere. When it melts, the sea is darker, or the land is darker underneath it, and that absorbs more heat. And if you're like an architectural ninja, you dress yourself from head to toe in black and you go out in the hot sun, you're going to get really hot. Yes. And if you're relaxed and you wear white clothes in the summer, you're a little bit cooler. So the albedo, which is the scientific name for what color something is or how shiny that is really, really crucial. And it affects the whole world. That little bit of free ice changes the temperature in the countries all around the pole. And that is from this summer, this year, And these again, if you look at the figures, they're somewhere around 3.6 or more degrees warmer. When those frozen countries, when the frozen land gets warmer, it does change the relationship, and the land itself will emit carbon dioxide and, more crucially, methane. Methane is really crucial. We all emit methane. We know that cows do it from both ends, as all other ruminants do, and humans do, all living things do. But methane is 80 times more powerful than carbon dioxide as a warming gas. It's much shorter lived, but it's really, really powerful. And the amount of methane the world is emitting is increasing very rapidly, more rapidly than the emissions of carbon dioxide. So when that happens, the tundra and the frozen permafrost melts on the surface, and you start getting a whole surface that's made up of these meltwaters. Methane rich is emitting carbon dioxide, and that water will also get warmer, and permafrost will progressively melt at deeper levels. And if you live in the Northern Territories, in Russia or Canada, this is a really big problem, and you've probably all seen photographs of buildings and railway systems that are starting to subside. Permafrost had been there for thousands of years, and it's been heavily built on, but it's melting, and it's melting like crazy. When the water warms, then the things that live in the water rapidly increase. These are phytoplankton in the Barents Sea. Some of you will be familiar if you live in or have visited Venice or other parts of the world, particularly in the Mediterranean last summer, with the green algae, and that kills everything underneath it. It doesn't mean to kill it. It's simply because it's shutting off light and oxygen. But what it's also doing is inhibiting the absorption from the atmosphere of carbon dioxide. Okay, I'll just take a glass of water, if I may, once you look at a nice picture. Okay, Greenland, 3 kilometers thick of ice. You think that's never going to melt, you know. It's just so thick, it's not really a problem. But it's becoming a real problem. And it's already known that the meltwater is potentially going to change the circulation of the currents in the Atlantic. And that's going to affect the whole of the coast of Europe and of North America. And what's driving it is simply a change in salinity and fresh water. My cough is spreading. By the end of this lecture, you'll all be coughing, I think. Okay. So, I've grown up with these things, and you're used to it. You think this is a kind of normal thing. And it was thought that the circulation in the North Atlantic, which takes about 1,600 years for the cold water that sinks in the Arctic to travel all the way around the world and come back. But it was thought in all the IPC papers that it would be 100 years or maybe even 200 years before this changes. But in the last 3 or 4 years, there are signs that it is changing, and the flow is a lot weaker. It has collapsed in the past, in the very, very far past. Not in human times. No humans were alive when it did it. But this is the general pattern of the circulation, and the blue stuff is the cold water. And as the cold water pours off Greenland, as it's melting, it's changing this pattern. You can see, and there are many simulations from NASA, and there are live simulations that you can see every day of the pattern of these currents. And that is the Gulf Stream, and that's carrying the heat from around the equator up into the North Atlantic. The Gulf Stream drives weather for most of Europe, or certainly for the coastal regions and the coastal regions of North America. If that lessens, those areas will get colder, but there'll be much more intense rainfall and storms. So something weird is happening with rainfall, particularly the last 2 years, but probably in the last 7 or 8 years that I can show. And the diagram on the left-hand side over there, that's your left, right? My right. At the equator, the hot air rises, goes up into the high atmosphere. It travels and it cools, and when it cools, it drops down, and it carries rainfall with it. Very, very dry around the equator, and that traditional, where it falls down in the top of the Hadley cell, are the areas around the world that had significant rainfall. And this is changing, and it's these little yellow things on that other diagram that are doing it. The jet stream. Journalists call them rivers of water in the air, or phrases like that. They carry a lot of water, and they carry heat. But they're no longer in a nice, neat, circular pattern between the cells. Boundaries between the cells are less well defined, and the jet streams dip down sometimes almost to the equator and back again, or sometimes bend off to the north. And I'll show some really freaky rain things in a little while. What's really crucial about this diagram, these are all the tipping points. The blue ones are the changes in where ice is melting or where the temperature is changing rapidly. The green ones, those are the most significant for us, are where biomes are changing. Amazon rainforest is going through profound changes, and I will show you in a little while what they are. The boreal forests, which are the very northern forests, are actually moving further north, because what was solid permafrost is now melted. Trees can move there, but the southern edge is subject to drought, and those are dying off. So the northern forests are in effect moving north. And these orange ones are the patterns that are changing. These are the climate patterns and circulation that are changing. The West African monsoon, Indian monsoon, the Atlantic meridional overturning, which I've already talked to you a little bit about. These are all undergoing change. And wherever your home country is, if you're in a monsoon belt, you're hearing and you're living through this. These are the list, the current scientific list, actually from last year, of the temperature range at which any of the climate, the components of the climate system will go through the change, the 6 o'clock in the morning pile of sugar change. And if you look at this, this is what was promised. 1.5 to 1.2 degrees. Now, good scientists will say it was 1.5 this year, and maybe it was last year, but we have to wait 10 years to be able to say definitely it's 1.5. In my view, we'll be around 1.7 by then before they're able to say it's confirm it's 1.5. But if you look, Greenland ice sheet, West Antarctic ice sheet, tropical forests, tropical coral reef. We've all seen coral bleaching, and that happens every year, and it's getting more severe. The Barents Sea, Labrador, and the mountain glaciers. Mountain glaciers are really important, particularly if you live in the subcontinent in India. That's where all your water comes from. Nearly all of our fresh water in the world is locked up in ice. And as that changes, there will be profound floods initially, and then an amazingly and very serious deficiency of fresh water around the world. You'll have to stand out in the rain. Yeah. Okay. When the world burns, when the forest burns, it's not only local, the effect. So this is the effect of forest fires occurring in Canada and the USA. All the carbon that was locked up in the trees, of course, is released, but there's also black carbon, little soot particles, little fragments of burnt wood that are in the atmosphere. And they carry with them other dangers. We've been living with drought, arguably very seriously around the world for about 7 or 8 years. Most of you in your home country will have had some experience of that. If you live in the USA, most of the water reservoirs that are fed by natural water are like this. You can see a kind of rim around it, like a bath that hasn't been cleaned. And where it gets darker, that's where the water used to be. And this is a water reservoir that feeds people in a city. This is in Spain in August this year, down to 7% of its capacity. Photographers always like to include a little ruined boat in these kinds of photographs, so when you see them, there's always a little boat in them somewhere. But when you look at the aerial photographs over the whole course of a river, this is the same river in Spain, you can see how profound that drying out is. And there's no life without fresh water, not animal life, not plant life, and certainly not human life. Also in Spain, vast reservoirs close to cities. In California, I think San Francisco and LA import a great deal of their water. And they built pipelines from the Sierra Nevada, which are hundreds of miles long. There are some cities, like Dubai, which only have a 48-hour supply of water. And if the next shipment or the lorries and ships bringing it in fail, then everybody's going to be really, really thirsty. This is from a press release from the president of Brazil from this summer, that the Amazon is suffering a drought that is more severe than it has been for 40 years. And you can see these things very clearly. That's always, when trees dry out, they become very susceptible to fire. And of course, in some areas, particularly the Amazon, people are deliberately setting fire to clear land. It's not just in the Amazon, it's happening in many parts of the world for agriculture. Some of it is venal, for profit, but some of it is simply there are so many humans that we need more and more food to feed the growing population. And for the first time, we know that the Amazon in 2024 emitted more carbon dioxide than it absorbed. And this is super serious. Every climate model has built into it the understanding that the Amazon is one of the great carbon sinks of the world. This is what those trees will capture the carbon and store them. You can see here, I think this is in Morocco, the difference between last year and this year. It's Casablanca. I once took my students, and then I was a unit master to Casablanca, and I lost one student who just got off the bus because he loved Casablanca. But it is a very significant change. Rainfall patterns are changing. They have changed. There is rain still falling. There's more water in the atmosphere, but it's no longer falling where we're used to it falling for the last several hundred years. This is South Africa, in my youth famously green, now becoming very arid. But something else really weird, when you look at the map of the rainfalls or the excess amounts or the diminution, the sort of reddy brown stuff is where there's much less rainfall this year than last year and much less than in the past. And the amazing blue bit is where suddenly in the Sahara there have been massive rainfall. And those of you from the region will recognize this picture. This is the Sahara. Now, of course, we know the Sahara was once green, probably about 2,500 years ago. And if you read about the Caesars and Rome and early Greece, people were hunting lions and so forth here. It doesn't mean this is going to be wet yet, but just an example of how these what were very steady and reliable patterns have changed. And in England, let me tell you, if you're new to England or this is not your home, don't drink from an English river. And definitely don't go swimming. And we're not alone in that. I think in the Paris Olympics, in the triathlon, when they all had to dive in the River Seine, and then most of them spent the next 48 hours in the toilet. Okay? These are dangerous. But what's truly shocking is that 85% of all the rivers in the UK are in poor ecological or bad ecological health. And 75% of them is actually harmful to you to go into them or drink the water. But we rely on rivers. This is where we get our water from. This is what we feed our animals with. This is what we put into reservoirs. And when you turn on the tap and you want to drink, this is where it comes from. And the UK is not alone in that. Mining is one of the biggest pollutants around the world. This study showed there are up to 300,000 miles of polluted rivers around the world that are polluted with heavy metals from mining. And it makes an amazing photograph, but it's actually of immense consequence. And we like to think that we understand rivers. There's going to be a bit of flooding here and there, but still we build right up to the edges of rivers. We farm right up to the edges of rivers, and we channel the rivers in a way that is not natural to a river system. And designers of buildings and towns do not design for the river system from where it starts in the hills to where it ends in the sea. And this is one of the primary lessons for an ecological approach to design, that you have to understand the ecological system. So you can't just, if you're building or you have a commission to work near a river, it's not just that little bit of river that's your context. It's the whole river system and the whole basin that feeds it. And too often, this is the outcome. We build on what's called floodplains. Rivers in the past, I think particularly if you look at the history of the Nile, always flood at some time of the year. And it's that flood that enriches the soil, that produces the ecology of the natural systems around the river. But this is an outcome that has become very common. And I think in every country in the world, you will have seen scenes like this. And nobody designed those houses to be waterproof. In Holland, they have some designs where houses can float up and down on columns, but that's probably not the ideal answer. This is in Bangladesh, and it's a map that's showing the amount of rainfall in 5 days. And in the top little part here, It's in 3 days. But if we look at the very intense sort of vermilion color up at the top, that's more than 500 millimeters fell in 3 days. That's, it's up to here in 3 days. There aren't any systems that are known in the world that can cope with that intensity of rainfall. But in your lifetime, you are going to have to design for that. So here's some of the other problems that go along with this. This was a few days ago. You can track this. You can look it up, have it on your screensaver, whatever. You can see the numbers ticking up. I think what they also show on this site is the amount of ruminants, the cattle and the sheep and so forth, because their numbers are increasing at the same rate. And the big question is, are humans sustainable? We talk about sustainable architecture, but are humans? And the prediction is that we will go to 9 billion in your lifetime. Yeah, you're nodding there. Yeah. Of course, you'll be better looking than me when you're my age, but you'll be in a world of more than 9 billion people. And as it currently stands, there is not enough food or enough fresh water for 9 billion people. The ecological footprint. It's kind of a nice metaphor. What it means is, how much does any single individual or any single city or any single country consume of the Earth's natural resources? And the overshoot day is quite shocking. This year, this is the day on which the world has exceeded the use of food and water and natural resources of the world, exceeded what it can replace in 1 year. And this year it fell on August the 1st, but what's really significant is that journey, and it's only from 1970 that it's moved so rapidly. We are big consumers. We are eating the world. It's different, that's the average. It's different when you look at different countries. So most of us come from these countries on this side, and we can see how early that is. And on that side, Guatemala, Jamaica, Ecuador, and Iraq, maybe Venezuela and Colombia, and Peru, Mexico, consume far less. Politicians will tell you these are poor countries, or if they're being very polite, they'll say developing countries. Yeah. But life there is very different, and they consume less of the world, and they extract less from it. And this is not an easy problem. This is not a question of virtue. If you had orange juice this morning with your breakfast, probably it came from one of these greenhouses in southern Spain. Yeah. Certainly if you had a salad last night, your lettuce and tomatoes and all of that, that's where it came from. We've got used to the idea we can eat whatever we want, whenever we want, and it will come from somewhere else. When I was a child, admittedly a very long time ago, people ate what was in season. And your whole diet was based on what time of year it is and what's produced locally. But the cost of this, of you being like me, I went to Waitrose last night and bought some salads. The cost of that is that the runoff from these is producing these eutrophic waters. This again is the green algae. No fish can live under this. Can be no natural weeds or plants underneath of this. And the cost of this lecture, of the laptop and my iPhone and all of your stuff, is this. We are adding to the atmosphere and to the river systems and to the earth a huge number of chemicals and metals, and we rely on them, and our whole civilization is based on them. And I can't do without my iPhone, and you can't hear me if I'm not using this. And we produce stuff that we don't know how to dispose of. And arguably, people are moving towards bioplastics that will decay naturally. But some of the half-life of these, till they're partially half-life, is many hundreds of years. And this is all too common. The amount of gases and pollutants that are driven into the atmosphere from the burning of tires, because nobody knows what to do with all these tires. I don't know the world population of cars. Most of us have one, or would like one, or used to have one. And car tires last 3 or 4 years, something like that. But they have to be disposed of. And we don't have a good way to do that. Shipping is one of the primary causes of outgassing, because they burn a very dirty diesel for their engines, but they're extremely difficult to take apart. This is from Goa. The long-life hydrocarbons that are really toxic are resulting in second-generation birth defects from the people who work on this and take these apart. And rare earth metals. There's no computation of any kind without rare earth metals. But some of the mining, like this one, will produce scars on the landscape and that will last up to 500 years. So it's nearly all doom and gloom, but there's some more optimistic bits as we get to the end. But this is the list of things that I've been talking about and the changes that are currently happening and are accelerating. They're getting bigger and getting worse. It's great that you're taking photographs, but it's being live streamed on YouTube, and you can check the YouTube to look at these things. All of these things are happening now. What's really interesting is there's a recent paper on climate scientists' private opinions, not what they write in the IPCC, which is like a room full of scientists bigger than this, and they all have to argue about, what's the least objectionable thing they can say, because I want to say that, and she wants to say something different. He doesn't agree with either of us. So we need to remember that's how IPCC reports originate. The common consensus of the least objectionable thing to say. That's how we're going to get Trump. Most governments and most elections work like that. But they're private opinions, and I'll provide a paper if anyone wants it. I think it was about 350 scientists who had all contributed to the IPCC reports. None of them believed that 1.5 degrees was anything other than a political objective. And most of them think by 2100, it's going to be somewhere around 3 degrees or 3.5 degrees. The important thing to remember is it's not going to stop there. So you get the impression when they talk about 2050, 2100, that's the end of it, but it isn't. Some of you will have ideas about that. Now, just want to give a little example of what's happened in the past, more or less 100 years ago. And the Dust Bowl covered nearly all the way from Canada down to the southern USA. It lasted about 10 years. It was nicknamed the Dirty 30s, which you'll see why in a moment. And these were the common scenes. These were where cotton and wheat was grown, mainly cotton, I think, but intense agriculture that used up all the resources of the soil. And to make farms bigger, they cut down the trees. So there was nothing to stop when the wind came There's no trees or plants that could bind the soil together, nothing to deflect the wind, and it blew away. And this was 2 years after the previous slide. This is what remained. It provoked an incredible migration in the US, mainly to California and to Oklahoma. They were known as the Hokies. But this is the largest migration in US history was provoked by this. And the government did an amazing thing. They planted 220 million trees in a belt that was 100 miles wide and ran all west from Canada to the southern US. And there were big aquifers underneath. Those trees now are mainly gone, a lot chopped down. Many are dead because the drought has returned. And in parts of the US, they're starting to again become extremely concerned about the return of the Dust Bowl. When you look at the long ecological history of the US, the middle part of the US was once all sand dunes. And in some of my publications, I make the statement that the sand dunes will return. And what are we proposing as architects? This? Yeah. Does that compare to 220 million trees, a 100-mile wide corridor? No, it doesn't. It's insane. There is nothing there that can support the life inside of that. Everything has to come from somewhere else. And there are these fantasies, and I've done it and you've done it, when you make your drawings and things, and I'll put some green things on there. Yeah, you're laughing because you've done it too, right? Yeah. We'll grow some trees inside. Okay. It doesn't make any ecological sense. Frank Lloyd Wright proposed what he called the broadacre city. So every family would have 1 acre of land, and the city would roll across from the west coast all the way to the east coast of the USA. City without boundaries. But this is what was built. And in places like this is Dhaka, everything comes from somewhere else. There is no open space. There is no green space. There are no bodies of water, no wetlands, no marshes, nothing. It's just an endless carpet of undifferentiated buildings. And Mexico City. Yeah. If you were an alien, you'd think this was madness. But in one way it isn't, because there weren't any other choices. So one of your tasks as architects thinking about the future is, what are the choices? And we need to remember, for all the shining new cities and all the lovely diagrams you will see in Design of the 10 most interesting future designs for cities, that a significant fraction of humanity doesn't live in the shining city, they live here. And without dealing with this, there isn't any point to have new cities. There are parts of the earth where there are evolved systems. Quite beautiful. Of course, they do produce methane and carbon dioxide, but the landscape is ecologically managed. So we come to net zero. You've all heard of that, haven't you? In the UK, they promised 2050, we're going to have net zero. So what does it mean? It's a balance. On the one hand, there are emissions and they will continue. On the other hand, we will extract from the atmosphere carbon dioxide and other pollutants. And net zero is when those two are in balance. It's a good scientific idea. Can we do it by 2050? The UN says no. We're nowhere near that. If you listen to your politicians, they say, yes, easy peasy. We're certainly going to do it, but not in the 5 years that I'm in government, but the next lot will do it. And there are two really big fictions which are dangerous about the current attitude to net zero. Firstly, biological carbon capture. We just have a lot of trees, and they'll just do the trick. I've shown you what's happening with the Amazon. Trees arguably take 10 to 20 years to grow, and it takes about 100 years before a forest will have enough mass and layering that it's a significant carbon sink. The other part of that is social justice or climate justice. I'm going to carry on polluting here, but I'm going to pay you, because you live far away in a very poor country, to plant some trees or do some climate stuff. Right? Those countries need to have a very different gift from the richer countries. Yeah. Not to carry the burden, but to help them make their own ecological systems better. Okay. So where will you be in 2050? Okay, it's not far away. 25 years, yes. You'll still be young and handsome. Very nearly. Not quite so much. But where will you be? You need to understand in your home country what's going to be happening in 2050. When I was a student, I was told, when you design a building, it's only got to last 5 years. If it lasts for 10, it's in profit. And never mind. This building is, does anyone know how old this is? All of these squares were laid out in the 19th century. And contrary to the kind of architecture I was taught, where you exactly studied the program and you matched every space to every detail of the program, these spaces are very generic. They could be used for a lot of things. And in 50 years, 2074, you will be very nearly as old as I am, inshallah. Yeah. What will you be saying? Some of you will be standing here or in places like this. You'll be inhabiting a world that has already gone through profound changes, and you'll be talking to people about the changes that are yet to come. Climate change has no end. Okay. A little more than 100 years ago, 110, Saint-Hilaire and his contemporaries were facing a very similar set of circumstances to now. Rapidly expanding populations, the destruction and detritus of warfare, what were then socially explosive technologies that were changing social structure completely. Yeah. And they had an implacably unenlightened repressive orthodoxy, which is a set of phrases that I would describe most Western governments. They know very well the science, but they have an orthodoxy to what should be done, and it's more important for them to keep to their political ideology than to look to the future. And in most countries, politicians are in power for 5 years. And maybe not all of them are terribly bad, but they all have a 5-year viewpoint. And I think you should have a minimum of a 25-year viewpoint. And in 25 years, many of you will be leading big practices or have your own practices, or you'll be leading academics. And you will have this task again for the future. That, on the left, was once one of the best connected cities on Earth. It's a very long time ago, so it's quite small compared to contemporary cities, and it's walled. But it was on the Silk Road, which you could say is the equivalent to a kind of internet superhighway. And they did all the things I've been talking about. They cut down the trees. They used up all the resources of the soil. They mined until all life could not be sustained. And the desert came and overtook it. Will you be facing these kind of dust storms? It doesn't have to be like that. There are things that you can do now, and particularly there are things that you can be designing and imagining for in 25 years' time. Okay. So this is one of the major themes that we'll be seeing. I think you're talking about regeneration in your talk. One of the major themes of this week, where people are talking about how we adapt to future change and how we can regenerate some part of the ecological systems of the Earth. It's arguably, we're somewhere around the middle. We know quite well, and you're being taught, I suppose, the science of sustainability. My own question is, I worry more and more that humans themselves are not sustainable. Nonetheless, we know a lot about sustainable architecture, and we have good science and good engineers, and they will be talking to you about that this week. This is much less well known. Can you design an ecosystem? Can you repair one that exists? And this is a fascinating field of study. It's also where you want to be because it's untrodden ground. Architects haven't been doing that. If you want to be original, you want to produce something of value, but to do original work, this is the territory you need to be in. We need to be beyond net zero. I've talked about some of the issues of that. But assuming that we can reach net zero, what happens after that? I'm hoping that this talk and some of the talks this week orientate you to the future. That you're not designing to solve an issue or to do something that's profound, of significance today. Of course, it's good to do that, and that makes life better for people. But the orientation to the future, the world depends on you. You inherit all the shit from the past, and it's left to you to deal with it. It's not fair, but that's where we are. You have many advantages, but imagination is really crucial. This, and my amazing Converse sneakers were all once products of the imagination. Someone imagined them once and they didn't exist. Yeah. Nearly every part of our life, things we depend on, were once just imaginary. They were once just dreams by young architects or young engineers or young designers. Don't underestimate the power of your imagination. Okay. Part of that will be, it's not just the morphology or the shape of things or what materials, we can all get better about that, but about designing communities that have new ways of living and that tread more lightly on the earth and that are in some relation to natural ecologies and the natural system of the world. And that's what this week is for you to discuss, for you to imagine, for you to listen, to ask hard questions of the people who are going to talk to you. Okay. And it's a whole week of it. And I think it's amazing. I hope you do too. Tonight, Tom Raymond will be with Mike Berners-Lee and with Kieran, I think. Tomorrow in the morning, we have Japanese bookbinding using, I hope it's using recycled paper. That's my excuse anyway, because I think it's just an amazing thing to do. Kate Davies and Jez Ralph are going to talk at lunchtime. They're from Hook Park. Hook Park has a 100-year plan for its forest. And they make amazing things there that minimize the processes that are done to natural materials. They work with timbers that are cut, that are being cut, and that have a particular shape, and they're not remachined to some preordained shape. And Bill Maguire is a volcanologist, professor of climate risk at UCL, is going to talk about how to live in a hothouse Earth. Assuming, and he's done that with his own life, assuming that the Earth is going to change, it's going to be 3 or 4 degrees, and he's going to tell you what he thinks of what we have to do, how to live in that. I'm a little bit over time, I'm afraid. Wednesday, our glorious student forum will be here and leading a discussion. Yes? Yeah. And Marco has organized a series of films which are all related to climate. They'll be shown in a Unit 7 space. There's a talk in the afternoon which a student forum have arranged, I think, with Yes Make. And there'll be a performance, I think, outside. There'll be further film show in Marco's unit, and in the evening, Kieran and Eliza will be making their presentation. Thursday is super full. Joanna is here, I saw her somewhere. There you are, yes. She'll be here at lunchtime. Climate resilience in the tropics for vulnerable communities. And I think this, as architects, as I said, we need to remember the vulnerable and the big fraction of humans that don't live in the shining city. There's a material swap, and Andrew Wally in the evening, who is the chair of Grimshaw, but actually taught a unit here. And it's an AA person who's going to come and talk about what Grimshaw has done and how they changed over the lifetime of the practice that he knows about. Friday is the big day. I'm not supposed to call it Pechakucha because someone has trademarked the name Pechakucha. But it's a series of rapid presentations. So this week, students will be making manifestos, little films. I think Diptem is making a short film in Glasgow. And they have the opportunity to present one after the other rapidly all day. We take a break for lunch, don't we? Yeah. 1 hour. You can eat a big lunch in 1 hour. I'm hoping we still have a couple of vacancies, that some of the units, if anyone's here today or sees it on YouTube, will say, yeah, I can do something. I can make a painting, I can make an image, I can make a manifesto or a little film. And the amazing thing is the whole of Friday is given over to student opinions. And I think that's how the AA should be. And in the evening, our last presentation is Rachel Armstrong, who's talking about architectural evolution and climate change. And she does some amazingly extraordinary, far out there work. She's primarily a biologist who's intensely interested in architecture. So that's the week, and that's my talk, and thank you for listening.